Okay, so we are trying to find out how many moles of each, actually grams, but first we need to find the moles to find the grams that is needed to make 400 moles of lead 2 sulfide. So we're going to find the mole ratio of not just one reactant but both, okay? So it's pretty simple. It's 1-to-1 mole ratio for the hydrogen sulfide, and then the mole ratio is 1-to-1 for the lead 2 chloride. So if the mole ratio is 1-to-1 for as many moles of hydrogen sulfide, how many moles? It takes 1 mole of hydrogen sulfide to make 1 mole of lead 2 sulfide. So basically you need 400 moles of the hydrogen sulfide to make 400 moles, right? And you need 400 moles of lead chloride to make 400 moles of lead sulfide. So that part's pretty simple. So we know that our answer is we need 400 moles of, and then we need 400 moles okay? So that's how much we need to make 400 moles of this lead 2 sulfide, okay? Now the next step is they asked for grams, so make sure that you're getting the amount that you need. Moles is just part of the way. Now we have to convert these to grams. And the way that we convert these to grams is we find the molecular formula weight for each one of these. Okay, we need to know how many grams of hydrogen sulfide and how many grams of lead chloride to yield 400 moles. Okay, so let me erase some of this so that it's a little bit simpler to read and find the formula weights. So the formula weight for hydrogen sulfide is 1 gram per mole times 2. That's 2 grams per mole of hydrogen. And the sulfide weighs 32 grams. We've only got 1, so it's 32 grams. So the formula weight for hydrogen sulfide is 34 grams per mole. Okay? So if it weighs 34 grams per mole and we need 400 moles of hydrogen sulfide, what we do is we multiply it times 400 moles. And the answer is 13,600 grams of hydrogen sulfide. So that's one part of our answer. That's how many grams of that element that we need to produce that many moles. Okay, now we'll work on the next element. That one, lead chloride. So let's find the formula weight for the lead chloride to find out how many grams we need. The molecular weight is, it's 277 total. Okay, so the molecular weight of lead chloride is 277 grams per mole. And if we need 400 moles of this element to make 400 moles of the lead sulfide, we just multiply that out, and that equals 110,800 grams of the lead chloride. That's how much we need in grams to make that much lead sulfide, okay? I know it's a lot of steps, but it's pretty simple. It's pretty much everything we've been doing with a little tad bit of a difference, okay? I have 2 more problems that I'd like, or actually just 1 more problem to practice with you guys. It's your page 245, and it's number 2. I picked the hardest one, I think. So number 2, page 245. problem says when iron is exposed to oxygen gas, rust or iron 3 oxide forms. If you begin with 25 grams of iron, how many grams of iron 3 oxide can you produce from this reaction? So first step is we're going to write out the equation. So we've got iron, okay, and it's exposed to oxygen gas. Oxygen gas is that diatomic gas. And it forms rust, which is called iron 3 oxide. So if iron 3 is a charge of positive 3, oxygen is a charge of negative 2. So the molecular formula for this is Fe2O3. That's iron 3 oxide, okay? This is how rust forms. It's called oxidation. So let's balance this equation. All we have simply is oxygen and iron. So we've got 1 on this side and 2 on that side. Got 2 on this side and 3 oxygen on that side. So I'm going to change this. And that changes into a 2. That doesn't change. This changes into a 6, and this changes to a 4. And then put a 4 here, a 4 there, and we'll put a 3 here, and that's 6. So now we're balanced out. Let me make that a little clearer. Okay, we're a balanced equation now. Now what we're going to do is look at what elements we're trying to figure out what's going on here. So if we begin with 25 grams of iron, that's what we're starting with. How many grams of iron oxide are we going to produce? Okay, next step, after we balance, mole ratio. So we're going to look at the mole ratio here. It's 4 to 2, which actually works out to being 2 to 1. That's our mole ratio. Now, our iron isn't in the form of moles, so what we need to do is convert that to moles, okay? So if we have 25 grams of iron, how many moles do we have? What does iron weigh per mole? How many grams per mole? So iron, its weight is 56 grams per mole. That's iron. And we have 25 grams. So I'm going to take 25 grams and divide it by 56 grams, and that's how we know how many moles we have. And that answer is 0.44 moles of iron. Okay? So in this reaction, if we have 0.44 moles of iron, that will yield how many moles of iron oxide? Well, our mole ratio is 2 to 1, so you just divide it by 2, okay? That mole, the amount of moles that you have, and that equals 0.22 moles of iron oxide. Okay? Do you get that, what I did there? If you have 2 to 1 mole ratio of this to this, and we started with 0.44 moles, we have half the amount of iron oxide produced in mole amount, okay? So this is how many moles of iron we're ending up with, okay? So Now we still need to know how many grams are we getting if we started with 25 grams of iron. How many grams are we going to get of the iron oxide? Okay, we have 0.22 moles that we know we have. And now we need to know how many grams there are. And what we do is we take the formula weight of this element and we multiply that by 0.22 moles, and then we know how many grams we have. So let's figure that out. We've got Fe, 2, and then O, 3. Iron weighs 56 grams per mole, and we've got 2. And then oxygen weighs 16 grams per mole, and we have 3 of those. Okay. So that's 112 grams plus 48 grams. And that equals 160 grams per mole. That's how much iron oxide weighs. And if we have 0.22 moles of that, that ends up equaling 35.2 grams of iron oxide. And that is your answer. So that's pretty much all. That's the hardest problem I found in the chapter and the practice questions. So I will send you girls the solutions. If you're having trouble understanding this, let me know, and I will maybe send you some other videos that maybe explain it better if this doesn't work for you. It's just a tiny little bit of a difference of what we did last week. So just let me know if this works for you, okay? I hope you have a good week. Thank you. Have a good one. Bye.